Locked in the earth are the riches that propel our modern world. And woven throughout the course of human history is the saga of a perpetual search from the mines of King Solomon to the black gold of the 20th century. Gathered from Earth's far frontiers, they have built the tools of war and the cities of peace. In the rocks of planet Earth are the raw materials of our technology. And from the Earth we have fashioned the monuments of our modern age. A few thousand years of human civilization is linked to an ancient struggle of titans, as the power of the sun and the forces within the earth wrestle over the thin crust that wraps our planet. Over hundreds of millions of years, they have created and distributed the great treasures of this earth. Around the globe, scientists search to understand the creation of Earth's treasures. At the heart of the search, two urgent questions. How long will they last? And to find them, how far must we go? A cedar swamp in Maine holds clues that may affect the energy resources of tomorrow.
We need to get farther in.
Find a good exposure of it.
In a subterranean world, scientists unravel a geological mystery of incredible wealth. And in the skies, high above the Nevada desert, new eyes of science look down on Earth. What they see could revolutionize our understanding of the planet. Scientists have entered a world that until now was unexplored. Our future will be determined by what they find.
Annenberg Media.
Corporate funding for Planet Earth is provided by IBM. IBM is proud to support the innovative spirit of scientific inquiry that made this series possible.
In New York City, a world-famous auction house offers items of exquisite design and extraordinary value to a discriminating clientele.
For $24,000 now, $25,000, $26,000 is here. I had $26,000 for it, $26,000 at $26,000. The bid's up front and against the room now at $26,000 all done. Sold for $26,000, Edith Black. Sold for $110,000. Sold now for $135,000. All right, what should we say to start this? $500,000 to start it?
In the bidding over a flawless blue diamond, it is easily forgotten that these works of elegant beauty were transformed from stones dug from the ground.
$850,000 at $875,000 now. $900,000 in the center of the room now. Down it goes then at $900,000 in the center of the room at 900. 900.
Stones of astonishing value. Yet of far greater worth than the brightest diamond are mineral treasures that have played a pivotal part in human history. In Pittsburgh, at the Carnegie Institute's Hillman Hall of Minerals, fantastic specimens are displayed and admired as works of art. Formed by forces originating deep within the earth and from our distant sun, they are of a seemingly infinite variety. Incredibly, they are all examples of nature's artistry, transformed by water, molten heat, sun, and time. Exquisitely shaped, economic and precious metals alike rival the finest creations of craftsmen. In a museum gallery, they are treasures from a jewel box earth. Although the treasures of the earth are widespread, the places where they are concentrated and accessible are not. The splendor of gold and silver light our world, as if glittering brightly from afar. Royalty among metals, they are mined in but a few regions around the globe. Shining forth are the sources of our most basic metals. Among them are lead, zinc, copper, and iron. Just 150 sites worldwide account for more than 3/4 of the metals and minerals essential to modern industry. Fueling the fires of our age are deposits of fossil fuels. Scattered around the globe, they are formed from prehistoric plants and microscopic animals of ancient times. In North America and Asia are the major deposits of coal. Oil and natural gas are spread among the continents, but a full 60% of the world's known supplies are beneath the Persian Gulf. Petroleum dominates modern history, much as another resource dominated the Mediterranean world of ancient times. From the froth of the sea came Aphrodite, goddess of fertility and love. A Greek poet named this beach in Cyprus as her birthplace. Aphrodite was born into the richest land in the classical world, for in the mountains that rise from this sea lay a phenomenal treasure, the copper mines of ancient Cyprus. Copper ingots bearing the stamp of Cyprus and cast in the shape of hides were carried throughout the Mediterranean world. Under the patronage of the Mycenaean god Enkomi, the island supplied much of the copper for the Bronze Age. From its mines and smelters came the utensils of the hearth. Other anvils forged the metal into instruments of war. Cyprus, in fact, means copper, and from 4,000 years before the birth of Christ until the decline of the Roman Empire, the mines of Cyprus were as vital to the ancient world as the oil of the Persian Gulf is to modern times. Today, ruins and deserted caverns are all that remain of that great age long ago. The mines of Cyprus lay idle for 1,600 years. But in 1913, after studying the accounts written by ancient Romans, an American geologist rediscovered the mines. Once more, they yielded up their riches, and mine tailings dotted the foothills of the Troodos Mountains. By the late 1950s, Cyprus began to interest geologists for other reasons. Gorgos Constantinou, now head of the Cyprus Geological Survey, and Dick Hutchinson of the Colorado School of Mines studied the ancient sites for clues to a geological mystery. Clinging to the wall of an old pit mine is a small pocket of metal ore, a remarkable type containing copper, gold, silver, and zinc. They thought that these deposits were formed when the minerals were forced into existing rock, replacing what was there before. But that process would not have produced the layered bands that they found.
Sulfide band. When I first came here to Cyprus in 1962, our understanding of the origin of these rich concentrations of metals was, at best, very poor. We believed they had been formed within the rocks long after the rocks had been laid down by a replacement process.
But the layered bands contradicted that theory, forcing them to find a new explanation. Little did they know that they were on the verge of a new scientific breakthrough. Nearby was evidence that further challenged the old theories. Geologists found large swirled rock formations referred to as pillow lavas. These, they knew, could only be formed as hot lava came in sudden contact with cold seawater. Could the metal deposits in the pillow lavas have formed together on the sea floor? These remarkable pictures capture a drama similar to what took place on the floor of an ancient sea. Lava hardens into pillow shapes as its molten fire is quenched by the seawater. The trail of the metal ore and the pillow lavas led to a whole new theory of how Cyprus formed, part of a revolutionary view of our planet based on the concept of plate tectonics. The Earth's crust, far from being solid, is cracked like an eggshell. The surface is broken into huge slabs or plates that slide about like a crust of lava slides over a molten lake. Geological events on a colossal scale are the result of this dynamic, evolving Earth. Mountain ranges rise as continents collide. The Himalayas were thrust upward and continue to inch ever higher as the broad arc of India pushes against the belly of Asia. Along California's San Andreas Fault, earthquakes occur when the tension between plates is released in sudden spasms. The shearing and breaking of solid rock has formed the great scar of the Carrizo Plain. On the seafloor is the Earth's largest geological feature, an underwater mountain range that wraps the world in a jagged furrow 46,000 miles long. At this ridge, formed as the Earth's plates pull apart, molten rock from the Earth's interior rises to become new seafloor. In the ancient Mediterranean Sea, this same fiery genesis occurred, where the African and European plates tugged against each other. Approximately 40 million years ago, the process reversed. The African plate plunged beneath the European plate, and the area that became Cyprus was pushed upward. Ancient formations from the deep sea floor became the mountains of Troodos. On its flanks rested the pillow lavas from the seabed and the deposits of metal ores. Cyprus was an important clue to the mystery of how such deposits were created. The next clue would come from halfway around the world. Japan. Land of living volcanoes, fed by immense heat and molten rock flowing from the interior of the Earth. The length of Japan is laced with hot springs and mud pots, an intrinsic part of the Japanese landscape. The agricultural valleys of northern Japan are famous for their rice crop, but the real wealth of the region lies beneath these rice paddies. 900 feet below the surface are a unique combination of metals. Compounds of copper, gold, silver, lead, and zinc, almost identical to the ore found in Cyprus. In Japanese, it is called kuroko, black ore. Japanese geologists speculated as early as the turn of the century that the deposits they were mining might have been formed by hot springs. Because no papers on the subject were translated from Japanese, Western geologists would not learn of these theories for another 4 decades. Preserved in the mines is further evidence that links the black ore to seafloor hot springs. Volcanic rocks mixed with the ore. A bright red rock thought to be left by a dying hot spring. Clues frozen in stone complete a theory of how the deposits formed. Drawing on their research, geologists construct a model of something no one has ever seen. They theorize that millions of years ago, there was hot spring activity on the seafloor. Water trickled down through fractures in the seabed created by plate action, and then, heated by volcanic rocks deep within the earth, circulated upward, carrying a variety of minerals with it. When water came spewing out of the cracks on the seafloor, the minerals carpeted the bottom. Jutting from the very top of this hypothetical hot spring was strange-looking chimneys of different sizes, stacks built by the minerals pouring out like black smoke. The Kuroko mines have now become a focal point for exploration geologists from around the world.
And on the side of the
Steve Scott from the University of Toronto first came here during the 1970s. Now he has returned with a group of his colleagues to share this unusual laboratory. The open pit was mined for over 100 years. As they move across it, the scientists walk through what was once the interior of vents and chimneys that carried the black, metal-rich water up to the seafloor.
Oh, yeah.
What is left behind is a rare display above ground of what they believe was a system of hot springs at the bottom of an ancient sea.
Disseminated pyrite, iron sulfide. We have volcanic fragments here. You can see that they're 10 to 30 centimeters in diameter, and the hydrothermal fluids came up around these to feed the black smokers, which would have been about 50 meters up there. In other words, we're standing 50 meters below the seafloor here.
In 1977, on an extraordinary day for science, the evidence from Japan and Cyprus is to be confirmed. Off the coast of Mexico at a site named 21 degrees north, the research submersible Alvin explores a dark frontier where 2 plates are pulling apart. In a blackness never before penetrated by light, geologists witness firsthand the process that formed the deposits in Japan 13 million years ago, and in Cyprus 30 million years before that. The chimneys of the hot spring are given the most obvious of names, black smokers. The metal-rich water is so hot that it melts Alvin's sensing probe. The researchers return to the surface with the revolutionary news that the same process that formed the ancient deposits is occurring today. Scientists can now follow the telltale clues in search of other black smoker deposits. The trail leads them to the forests of northern Canada. Far from any ocean are large groupings of pillow lavas. Looking strangely like ancient cave drawings, they point the way. 2.5 billion years ago, this was the seafloor, and on it formed the richest black smoker deposit yet found, the Kidd Creek Mine. 2 shafts have been dug to 3,000 feet, and the ore continues still deeper. The value of the deposit is estimated at $30 billion. The trail that began in Cyprus and led to Japan does not end here. Since the discovery at 21 degrees north, scientists have found 17 black smoker sites on the ocean bottom. Along the 46,000 miles of spreading centers that circle the globe, there are undoubtedly others. Perhaps one has begun to form another Kidd Creek. Around the globe are a handful of ancient, stable areas, some nearly as old as the Earth itself. The most remarkable of these is in southern Africa, in a region known as the Bushveld Complex. When molten magma cooled here, it trapped within it one of the richest concentrations of metals known to man. In an area the size of Delaware are chromium, titanium, vanadium, and most importantly, platinum. Some 2 billion years ago, molten rock from deep within the Earth welled upward through weak points in the Earth's crust and pooled beneath the surface. Over the next 500,000 years, the magma slowly cooled, and the rich deposits of the Bushveld settled into a layer cake more than 8 kilometers thick. The Bushveld's most extraordinary feature is its platinum. In a continuous band, not more than a foot thick, but extending for miles, is over 3/4 of the world's known reserve of platinum. Though not as well known as other precious metals, the soft luster of platinum commands a price second only to gold. Hard, durable, with a high melting point, platinum will not rust or corrode. It is used to make lasers and coat razor blades. A metal is indispensable to the jeweled masterpieces of Cartier, as it is to the workings of a rocket engine. Buried together with the platinum is the mystery of how it formed. Why is this precious metal isolated in a single thin layer, the platinum at the top of the layer cake and the other metals at the bottom? The search for an answer is going on in Canada at the University of Toronto by geologist Tony Naldret.
This is a sample of the Merensky Reef, which is one of the largest ore deposits of platinum in the world. In fact, accounts for 3/4 of the platinum that we know about. And as you can see, it's a layered rock with this light-colored layer overlain by this much darker-colored layer. The platinum is contained as small specks of sulfide in this upper, darker-colored part. And recent research on the Bushveld complex has shown that the complex is the result of successive introductions of new magma. And it's when this new magma came into the chamber and mixed with the old magma that it caused the ore deposits of chromium and platinum to settle and form the layers which we now mine today. The process that we're talking about is very much like that which goes on in a smelter, and really the Bushveld complex has acted as nature's version of a smelter.
By reading the record left in the rocks, science can reconstruct events of an ancient past. Yet, even with new understanding of how the metals of the Bushveld formed, there remains another mystery. Why is so much of the world's platinum concentrated here and almost nowhere else on Earth? The magma of the Bushveld and the hydrothermal vents of the black smokers are dramatic evidence of the immense energy in the interior of the Earth. Energy that drives the planet's engine of creation. But the force that builds mountains and creates volcanoes is forever pitted against another, even more immense power, the sun. The fraction of the sun's energy that strikes the Earth makes wind blow and rivers flow. It is the sun that orchestrates the weather of the entire planet. Powered by the sun, the elements work to refashion the face of planet Earth. But even in the destruction they cause, a cycle of creation is set in motion. The beginnings of one of the most precious gifts of all, soil. The backs of mountains are broken into rocks and sand and clay. Living creatures and organic matter transform the dirt into soil, living soil. Almost half of each handful is bugs, bacteria, and microorganisms in their habitat of Earth. In life and in death, creatures in it and on it fertilize the soil. Most soil evolves from the weathering of bedrock. But here in the young volcanic earth of the Hawaiian Islands is a most unusual story. Weathering and erosion, the continual shuffling and moving and redistributing of the Earth's surface, is the focus of soil scientists. Carl Uehara of the University of Hawaii has found evidence of just how mobile the surface of the Earth can be. In parts of Hawaii, the soil is enriched by a gray clay, found to be 100 million years old. But there is a curious paradox. The volcanic islands themselves are only 2 million years old.
We suspect that this gray layer is the material that is blown in from the Asian continent and is scrubbed out of our atmosphere by heavy rainfalls. The significance of this material is that it is very rich in potassium and is the means by which much of this vegetation in this area received the potassium for its nutrition.
And so these young tropical islands, in part, owe their fertile soil to the dust from an ancient desert in China, far across the sea. At the end of the Ice Age, the soil in western Tennessee was formed from material deposited by colossal dust storms. The finely ground debris from the wake of glaciers, it is called loess. When early settlers came to this land at the bend of the river, it was covered in thick hardwood forest. They cleared the trees and plowed fields to make the breadbasket of the South. Today, the land is still rich and productive, but it is also victim to severe soil erosion. Each year, over 10 tons of precious topsoil is washed or blown away from each acre of cropland. At that rate, Tennessee loses 1 inch of soil every 25 years. In order to conserve this rich but fragile resource, a new breed of scientists now studies the formation and structure of different types of soil. John Jenkins of the Soil Conservation Service analyzes the overall health of this field by marking off sections or strata called horizons.
7 inches right here, and we have a good subsoil that runs down into the beginning.
Drawing his knife from the rich topsoil to the less productive subsoil to the dense clay below that stops any root or water, he can tell just how productive this soil is. The deeper he goes, the less valuable the land.
We're going to point out the rooting activity zone here. This is your surface layer right here, and if you look, you can see these little roots are pretty predominant, and there's a bigger root down in there. This zone right here is extremely silty, and it's laid down in what we call windblown silt or loess. And this area right in here tends to erode very easily.
The Soil Conservation Service is monitoring the erosion problem. Photographing it from the air is the work of Jim Bilyeu.
Soil erosion is not new. Geological erosion is well known. What happens when man comes along and disturbs the soil material and plants a crop in it? He accelerates the erosion processes. In most of the cropland soils in Tennessee that we deal with, we say that it will have a soil loss tolerance of 5 tons per acre per year. Now, what that simply means is, as long as we're not losing more than 5 tons per acre per year, then we're going to be able to maintain production well into the future.
In the natural order of things, the land will yield to wind and water. But science can help us to use the soil wisely and to slow down the inevitable.
I myself would say that soil is more valuable than oil or gold. You can't eat gold and you can't drink oil and survive, but you can grow food in good soil. So if it comes down to a matter of survival, are we going to have enough to eat, or are we going to have all the oil we want? I'll take the best land every time.
In the mountains of India begins a drama of sun and water. The sun, ultimate arbiter of nature. Not all the erosion caused by its power is for ill. High in the Himalayas, in snow and ice, the river Ganges begins its journey. Water, that liquid essential to life, is sacred in this river. Its holy beginnings are told in a Hindu verse. A torrent of water fell on the head of Shiva, the destroyer. Running down a lock of his hair, it became the river Ganges, flowing from the top of the world to the sea. The sacred waters of the Ganges tumble down from the mountains to begin their long descent. To Indians, it is the river of life, and the entire drama of this world is played along its course. At Benares, the holiest city on its banks, the river is a temple of worship. As they carve their way through valley and plain, the sacred waters carry organic flotsam, silt, and sand. Where the river meets the sea, much of this matter is trapped together in the huge fantail of the Ganges Delta. Seen from space, the tangled pattern of the delta takes on a new dimension. It is a natural bowl being filled with mud and organic matter carried by the river. The deltas of rivers around the world are places of natural alchemy. In these environments are created coal, oil, and natural gas. The Mississippi River, liquid highway and watershed for the heart of North America. In its delta is deposited the outwash of a continent. Over millions of years, sediments have piled up 10 miles thick beneath the muddy waters. Here, in a natural chemical factory, they are transformed. In the geological magic of a sedimentary basin, organic matter is trapped and accumulates before it has a chance to decay. As the amount of sediment grows, its increasing weight actually presses down on the floor of the basin. And over time, the organic matter is transformed in a natural pressure cooker. Now there must be a layer of impermeable rock laid over the deposit. Without such a cap, the riches of a potential field will simply drift away. As the mighty river flows, the cycle continues. The fossil fuels of the future being formed even as we mine the living matter of the past. Vast deposits of fossil fuels can have modest beginnings. This cedar swamp in Maine may one day be a coal field. Even now it has begun its transformation. As moss and other aquatic plants begin to take over the swamp, organic matter accumulates in the low oxygen environment of the bog. Gradually, peat begins to form, the first step in the creation of coal. In the search for clean burning coal, scientists are studying the formation of peat bogs like these that have low sulfur content. Understanding the conditions under which they form will increase the chances of finding clean burning coal in the future.
Station 4000.
Past her 70th birthday, Cornelia Cameron has mapped peat bogs for the U.S. Geological Survey for the past 30 years. Because the summer months mean slogging hip-deep through the mire, her work in Maine begins early in the spring, while the surface is still frozen.
It's much easier for traveling.
Once through the ice, she uses a coring tool of her own design to sample the thickness of the peat. Sample after sample, she can read the history of the bog, a history that, when analyzed in the lab, may reveal clues about the bog's future.
Look at the grass of the marsh. This is sphagnum peat and moss. This deposit of peat is made by the building up plants on plants of the type of plants that you see right here, the shrubs.
20 feet of core reveals 12,000 years of history. Beneath the 15 feet of peat are the remains of a forest. Below that, a freshwater pond. And at the very bottom...
Ah, we're in the clay.
The sticky clay was laid down at the end of the last ice age. The sea followed the retreating glacier, flooding this part of New England.
This part up here is in the freshwater pond. The peat deposit that you see all through here was laid down on the marine clay. Many coal beds are laid on marine clay, and then they're covered up. If this deposit was covered up by another invasion of the sea, maybe in a few millennia you'd find coal here, but maybe.
It was king coal throughout the 19th century, the raw material that powered steel mills, factories, and railroads. Today, despite environmental problems, coal still plays a major industrial role around the world. By far the most abundant of any energy source, the challenge is to find coal that can burn hot and clean. In the search for oil, approximately 3 million wells have been drilled in the United States. Several 100,000 more have been drilled in the rest of the world. The days of wildcatting and gushers are probably over. Today, the search demands a highly coordinated effort of men and machines. Beyond the edge of a continent is a search for oil. 200 miles off the coast of Newfoundland. It was not far from here that the Titanic, the ship that couldn't be sunk, collided with an iceberg and went down on her maiden voyage. These semi-submersible rigs are floating outposts, staffed with crews of over 100 people. Their immense legs contain drinking water, a power generator, a sewage treatment plant, even a small gymnasium. The platform floats in a frigid sea, its ballast constantly monitored and adjusted by computers. This rig cost nearly $100 million to build. It costs $250,000 a day to operate it. But high cost is not the only risk in this hostile environment. Floating mountains of ice the size of city blocks move down from the Sea of Labrador into the North Atlantic. For the past 54 days, this rig has not been able to drill because of sea ice and the menacing presence of icebergs. If an iceberg should collide with a drill rig, it would be certain disaster. With 150 feet of it above water and 300 feet below, a mountain of ice weighing 6.1 million tons drifts across the sea toward a flagship of technology. Only the constant vigil of men and machines makes such exploration possible. Only modern civilization's great dependence on oil makes it necessary. The long search for oil begins in offices and research laboratories, where science plays a crucial role. Core samples from around the world reveal the histories of ancient environments. They are layers of time etched in stone. A plug from a core sample is ground to microscopic thinness and colored with special dyes. It can lead geologists to the unique kind of rock that will hold oil. Between the particles of stone, minute droplets of oil and water are held, much like a sponge holds liquid. Processing data from a satellite, the computer outlines hidden contours and stream beds that may reveal clues to the geology beneath the surface. But the most critical decisions are not made by machines. Guided by a map of the sedimentary basins around the globe and drawing on their knowledge of plate tectonics, petroleum geologists like Don Ziegler and Kerry Mrozowski lead the search. Of the some 600 known sedimentary basins around the world, only about 125 have produced oil or gas. The educated guesses of these men carry high stakes.
In the plate tectonic scheme, the breaking up of the continents, one of the key ingredients is that when the continents split apart, they break on about a 120-degree angle. and one of the breakages will take over, and the other breakage that is left behind is called a failed arm. And because it was a rifting area and subsiding area, it captures a lot of sediments, and it becomes a site that can be very favorable for oil accumulation.
Plate tectonics is the catalyst in a bold plan to explore for oil where no one had ever looked before. The Sudan in Africa. There are no clues on the surface that beneath the scrub forests and arid landscapes, there might be the structures that trap oil. Seismic studies play the crucial role in deciding whether or not to drill a well. Like sonar, seismic devices probe the Earth with sound. A cross-section portrait of the Earth is gathered from the reflected waves of an explosive charge. Geologists interpret and mark the resulting maps to reconstruct the various levels of the basin as sediments were forming. In the research laboratory, wall map and pens are aided by the very latest technology. The computer slices through a three-dimensional chunk of the Sudan like slicing through a loaf of bread. Each red line, or picking, isolates information that is used to construct a three-dimensional picture of the subterranean world. Like geological time travel, the computer peels back the skin of Earth to reveal part of an ancient freshwater lake. Once flat, it has since been tilted. The slope is color-coded by the computer, from red at the higher end to blue at the lower. It is an environment that could have trapped oil. The tools of science have revealed what human eyes could never see. An important decision is made. The first well was dry, but 1 year and several wells later, commercial amounts of crude began to flow. The exploration in the Sudan is a success, but it is also a preview of the future that will require all the knowledge and tools of science. At the NASA Ames Research Center near San Francisco, a specially equipped aircraft prepares for takeoff. The converted C-130 is equipped as a flying laboratory to test and develop a new generation of exotic instruments. Scientists know these machines by the general label remote sensing, instruments that see beyond the range of human vision. Developed as sensing devices to radio back information from other planets, these machines provide valuable new insights about the surface of Earth. One of the newest of these instruments is the Airborne Imaging Spectrometer, known by its initials, AIS. It is being tested in skies over Cuprite, a remote mining district in the Nevada desert.
Line start 17:53:51.
Camera started at 245.
I think that's it right there.
Okay, where it looks like the gravel pit's dead center on our TV screen here.
The Jet Propulsion Laboratory in Pasadena, California, where AIS is being developed under the guidance of Alexander Getz.
The AIS is the first step in a new generation of machines that will eventually allow us to prospect from space. Now, these machines are different from earlier satellite instruments in that they allow us to identify specific minerals which are indicators for deposits buried below. This is done by taking pictures in many different wavelengths in the infrared beyond the range of human vision.
The reflected light of each wavelength is combined to form a graph, a unique curve that identifies each mineral. The computer is loaded with the graphs of over 200 known minerals. It scans an AIS picture of the ground in a swath 1,000 feet wide and 3 miles long. The computer is able to compare each of the known minerals with the data recorded in the air and actually identifies the different minerals on the surface below. On the narrow map, the computer then colors all the locations of each mineral. The blue, yellow, and red colors seen from the air all relate to minerals found together with gold. In a puzzling development, it also marks the location of a mineral that the computer cannot identify. Guided by the computer-drawn map, Getz and his assistant, Greg Vane, make the long, dusty trip to Cooperite to look for a sample of the mystery mineral. Getz and Vane make use of a new kind of tool in their search. A small version of the spectrometer flown in the aircraft acts as a homing device to lead them to the area marked by the computer.
Yeah, the ratios look good. I think we're right on the money.
Okay.
Looks pretty good.
It looks no different from dozens of other rocks lying about. But the spectrometer indicates this rock contains the mineral they are searching for.
Uh-huh. That's probably a sample we ought to take.
When analyzed by the U.S. Geological Survey, it will prove to be a rare discovery of an obscure mineral called buddingtonite, a possible pathfinder for locating deposits of gold.
Remote sensing measurements will never replace the geologist in the field. But with the new instruments that we have now, the new kinds of measurements like imaging spectrometers, and in particular the airborne imaging spectrometer, we can make measurements that allow us to see things that can't be seen by the eye or can't be seen by a geologist.
This kind of remote sensing will speed up mapping of minerals on the surface by orders of magnitude. What once took years by conventional methods can now be done in an afternoon, and with far greater detail than ever before. Flown on the space shuttle and on a space station, AIS has the potential to map for the first time the surface minerals of the entire United States, and perhaps the world. As we begin to acquire a global perspective of the Earth's great gifts, this new technology allows us to see our world in a completely new way. Probing with electronic eyes, satellites reveal the face of an Earth at once familiar and unexplored. We know little of what lies beneath these rugged landscapes and icy terrain. We have learned more about our planet in the past 30 years than in the previous 300, and yet much of the interior of the Earth remains a mystery. Understanding the forces that fashion our world is becoming increasingly important. It is clear that the metals and minerals of this restless Earth are being used more quickly than they are being created. If civilization is to continue in its present form, the search for new discoveries will go on, possibly even beyond our own planet. In that search, there will be yet newfound knowledge about the wondrous ways the Earth is shaped and formed. And perhaps the most precious discovery of all will be a new understanding of planet Earth.
Annenberg Media. For information about this and other Annenberg Media programs, call 1-800-LEARNER and visit us at www.learner.org.